tell you about the context of the lunar exploration and how the Chandrayaan series of the missions from our country, India, are making a difference in the global understanding.
Yes, sir.
Okay. So let me continue. So to start with, I will give you a very brief introduction about uh, what all constitute the space exploration. And after having given, I will be very much specific about the solar system exploration, and then we'll go to moon. So when I'm speaking before you on behalf of the Indian Space Research Organization, um, let me tell you today when I'm speaking with you, lot of transformation has happened in the organization itself and also in the understanding about the space. When I am telling about the understanding of the space, I mean right from the surface of the earth, above the surface of the earth, the understanding of the solar system and also the domains of beyond the solar system in the realm of astronomy, astrophysics. Lot of transformation has happened in our understanding and also transformation has happened in the organization. So here at when I'm speaking with you, we are going to speak about four major particles as far as the science is concerned. One particle is the solar system exploration, in which we study about the different bodies in the solar system, including the planets and the artificial satellites, the small bodies in the solar system, then dust in this interplanetary medium. All these things comprise the solar system exploration. And the moon exploration, lunar exploration, is a part of the solar system exploration. Then, of course, we have other domains like astronomy, astrophysics, solar and heliophysics, where we study the sun and the influence of the sun to other members of the solar system, and also another branch which is the near Earth space. So, in today's discussion, I will restrict myself to the solar system exploration, that too in the domain of the lunar exploration, to give a brief overview of why we should study the moon and what did Chandrayaan series of the mission do to add values, scientific values to the understanding of the moon. Now, this slide is basically to apprise you that ISRO at present works in the domain of space sciences by virtue of modeling, simulation, and observation. So when we speak about observation, we speak about both space-based observation and the ground-based observation. So as far as the space-based observation is concerned, we know what are those. We have satellites which are sent to space. We send observatories to space, or lander or rover. In the recent Chandrayaan mission, we have sent lunar lander and rover. All these are space-based observations. In contrary, we have a set of ground-based observations wherein we have different telescopes, antenna, all these things which are situated on the ground. So everything, starting from the space-based and the ground-based, they have something or the other to contribute to the observation of the celestial bodies. And this divides the domain of the space exploration into four verticals, as I have mentioned. So this is important to know because to many of the students whom I have interacted with, space sciences mean only astronomy, astrophysics, or somebody knows about India is doing moon mission, but it is much beyond that. ISRO's or India space missions are beyond astronomy, astrophysics, or moon mission or Mars mission. So it is a very systematic way of classification. This slide gives you an entire overview of the whole thing. Now the question is, it is good that we want to understand the solar system. The question is, to know our solar system, what are the things, what are the components in understanding the solar system? So when we speak about the solar system, we want to know about the science of the sun, the planets, natural satellites, the comets, asteroids, and dust, also the effect of the sun on the solar system bodies. But why do we want to know all this? We want to know all this because, first of all, for a bigger perspective, Earth is in the solar system, and it is imperative to know about our own solar system. That is the first motivation. Next motivation is you can translate the knowledge of your own solar system to the other solar systems, which is beyond your solar system, which we call exosolar system. In that exosolar system or outside somewhere else, other solar system, there may be a host star, there may be multiple of planets. So there may be a Goldilocks region like the one we have in our solar system, a region around the sun that satisfies the condition of hosting life. Similar condition might be there in the other solar system also. So this eventually points to the question, are we alone in the universe? Is there anybody else, other form of life or other form of intelligence elsewhere? So it all indicates to a bigger question. And also at the same time, when you want to understand the different kinds of planets in any solar system, may it be your own solar system, may it be some other solar system, you will appreciate one thing. You will appreciate that the planets are not of the same characteristics. Some planets are big, some planets are small, some planets are rocky, some planets do have magnetic field, some planets do have atmosphere. So they are all different. There's a zoo of different planets. So now the factors that matter to make planets different from one another include how much distant they are from the host star. In our solar system, we will say that it matters how far a planet is situated away from the sun. That is one of the factors you will agree. Other factors include the size or mass of the planetary body, whether there is any atmosphere, magnetic field, or whether there is enough internal energy in the planet so that there are manifestations in terms of any quakes, like we have in Earth, earthquakes, or we may have some moonquakes. Okay, or whether we have volcanism in moon, whether we have volcanism in Venus. So these are some of the questions. So now the factors which I mentioned, they are factors by themselves, and also they are the effects. You cannot distinguish between what are the factors and what are the effects, because they're all interlinked and they make the difference between one planet and the other. Now, when you want to study all these differences of the planets to understand your own solar system, as well as to understand a solar system which might be elsewhere, you will be very much interested to understand a certain domains of study. You may be very much interested to understand the geochemistry. You may be interested to understand the elemental composition, what all have been the building blocks in making of the planets. Or you may also be interested to know about the atmosphere that surrounds the planet. Okay, so these are the aspects, these are the domains, specific domains you would like to study in order to understand the planet. And when I say this, I also will tell you about um, there is something interesting. As I mentioned, different planets are having their own characteristic features. Mars is not like Venus. Venus is not exactly similar to the Earth. Earth is not similar to some other planet. Here we may also compare with the moon. As far as the planetary science is concerned, we really, when we speak about the comparison between the celestial bodies, we don't usually demarcate or differentiate between a natural satellite and the planet. So everything is planetary science. So how moon is different, how Mars is different, how Venus is different, all these things come to the question, the series of questions. Now, when you do this, you also will understand that each and every planet has got a potential to study some cases. What do I mean by cases? So let us understand this. See, what is the distance between Sun and the Earth? It is about 1 astronomical unit, right? Moon is also at a similar distance. That is 1 astronomical unit from the Sun. Now, if you compare Earth and the Moon, Earth has a very good atmosphere around itself. Moon doesn't have. Earth has a global magnetic field. Moon doesn't have. Okay, so if you want to understand how do the solar wind particles or the solar radiation interact with a celestial body which does not have any atmosphere, does not have any magnetic field, then moon will be the ideal celestial body to explore, to understand. Mars may not serve the purpose. On the other hand, if you want to study a planetary body which does not have any intrinsic magnetic field, which may have an induced magnetic field or a thin atmosphere, so that kind of body, how the solar radiation interacts with the planetary body, how do the solar wind particles interact with those bodies. If you want to study Mars, may be a case. So depending on your need to understand, depending on your question, each celestial body offers itself as the target of study. And that's how the study of the moon is important, because moon is a very unique celestial body, neighbor of the Earth, with a few features. So one feature is moon is airless. So when we say moon is airless, what we mean is, like the Earth, like on the Earth, we have pressure of say 1 atmosphere or maybe 1000 millibar. This kind of pressure is not imaginable in moon. The moon's pressure is much more less. Okay, so we call it an exosphere, and this condition starts right from the surface of the moon. On Earth, the condition of exosphere starts at a few hundred kilometers above, but that kind of sparsity of atmosphere starts right from the surface of the moon. So often moons is called a surface boundary exosphere. Those who many of you might know, but the important thing that happens is, since it is airless, all the wavelengths of the sun coming from the sun, they interact with the moon surface unhindered. There is no atmosphere, thick atmosphere, which could have absorbed some of the wavelengths. And another fact, that moon does not have a global magnetic field like the Earth has. That is also another reason for the unhindered incidence of the solar wind particles on the moon surface. So I'm not sure how many of you have heard the term solar wind. You know what is a solar wind? Solar wind are different ions and electrons which come out of the sun. So what are those ions basically? Almost most of them are hydrogen ions. About 95% are hydrogen ions, and a few of them, maybe 5% or less, they are doubly ionized helium. And a few of the ions are ions of heavier atoms. Okay, they come, and when something is ionized, there will be electrons as well, because charge neutrality condition has to be maintained. So sun gives out not only the sunlight, but also gives out ions and electrons. Those ions and electrons which come out of the sun, which are blown out of the sun, they are called solar wind. So what are the things that come out of the sun? These ionized particles, electrons, they come out of the sun, which are called solar wind. And also with the motion of the charged particle, there is another thing associated, that is there's a magnetic field. So with the basic knowledge of physics, you know that whenever there is a charged particle in motion with respect to a given reference frame or frame of reference, there is a magnetic field associated with the motion of a charged particle that many of you are aware of. So here also, when the charged particles move, they move along the direction of some magnetic field which are emanated and from the sun, and this magnetic field is known as interplanetary magnetic field, IMF. So all these things come from sun, radiation, solar wind, and interplanetary magnetic field. Now all of them are interacting with the moon. Radiation is coming unhindered, and when radiation is coming, what is happening? Your quick answer will be moon is getting heated. The day side of the moon is very hot. You cannot put your hand, because the day side temperature can go up to some, say, 400 Kelvin, and night side becomes very cold in the order of 100 Kelvin. So typically, if you remember two numbers, 400 Kelvin for the day side and the 100 Kelvin for the night side, it is enough. So moon surface gets heated up, very natural. But what else happens because of the radiation? What happens is when solar radiation comes, there is a photoelectric effect. So many of you know about photoelectric effect. So what happens when the high energy solar radiation come and interact with the atoms on the moon surface? Um, there is the photoelectric effect wherein the electrons are knocked out and there is a resultant positive potential developed on the surface of the moon, which is facing the sun. Similarly, there is a negative potential coming on the night side. So there is a charge difference, electrical charge difference also, depending on whether sun is there or not, whether it is the day side or night side. So that is one difference. Another difference is when the solar radiation comes, these photons deposit sufficient energy to the moon surface so that different trapped gases, different gas molecules, which are in the trapped condition, they also come out. So this is called photon assisted desorption. There are also other processes called sputtering, and I'm not going to those details. Okay, so that is one thing which happens. So this picture itself is so informative. One can spend a few hours to speak different facets of the interaction between the sun and the moon. But I will not go to that depth because I have something else to tell you. I am supposed to tell you about the lunar mission and the scientific context to give an overview. So I will just move forward. But one thing I need to tell you is that if you want to study moon and understand this kind of interesting scientific phenomena, what all the things you may like to study. You may like to study the elemental composition of the moon to understand what all the elements which constitute the moon's crust. You may also like to understand the kinds of minerals that have made the moon. That will tell you how the moon has evolved after its formation. Geology of the moon, different features. There is a subject called geology. This geology concept is also translated to the other celestial bodies. Sometimes people use the term selenology, but selenology term is not very much common. People speak about geology of the moon. Then study of the exosphere means study of the very tenuous, thin atmosphere of the moon. Or people also speak about the particle environment around the moon, the particles which are coming from the sun, or the particles which are coming from the extragalactic origin, cosmic origin per se. So all these things you would like to study as domains, given the condition, given the motivation to understand the moon for the sake of understanding the moon and to understand the moon-sun interaction. Now, with this backdrop, I hope I could impress upon you the need or the scientific motivation to understand the moon. And let me tell you, our journey of the moon, the Chandrayaan series of missions have been motivated by these kinds of scientific phenomena and scientific questions. And in this lecture, I am going to speak about our journey to the moon and a brief nutshell on what did India contribute to the lunar science and the experience of Chandrayaan 3. Because Chandrayaan 3 is the recent mission and many of you must be very much interested. Although there is a very detailed lecture on Chandrayaan 3 later. Okay, so let us see. So Chandrayaan series of missions started in 2008 with the launch of Chandrayaan 1, and the objective of Chandrayaan 1 was the mineralogical, chemical, and geological mapping of the moon from a satellite platform. And there have been several instruments, scientific payloads. A few of the scientific payloads were Indian origin. I have mentioned here HICE, TMC, LLRI-X. The MIP is the Moon Impact Probe. These were all Indian instruments. There have been European origin instruments, SAR-2, Radom, European Indian origin, that is collaboration between Indian institutes and European institutes. KICS, we don't call it C1XS, it is called KICS, C for Chandrayaan, 1 for 1, Chandrayaan 1. We pronounce as KICS, SARA, another instrument. And United States gave Moon Meteorology Mapper N-Cube and MINISAR. So, Chandrayaan 1 itself is a topic which can keep you busy for a few days. Each and every instrument has given so much of science. It is worth discussing about each and every instrument, their capabilities, what science they have given. It's a plethora of things. But in our limited time, I will just impress upon you what is the significance of Chandrayaan 1 in terms of the value addition in the science of the moon. That I will share you. Then Chandrayaan 2 flew in 2019 with a gap of 11 years. You have to see. Now, when Chandrayaan 2 flew, Chandrayaan 2 had a set of instruments which were, in the course of my discussion, I will tell you how these instruments were chosen. They were chosen based on the scientific results of Chandrayaan 1, and the objective was same, the chemical, mineralogical, and geological mapping of the moon. And many of you are aware that Chandrayaan 2 had initially 3 components, the orbiter, the lander, and the rover. But we could not do soft landing due to some technical reasons. So whatever we wanted to do in terms of soft landing and the roving of the moon surface, we could not do during Chandrayaan 2. But the Chandrayaan 2 orbiter, with a suite of 8 instruments, kept on studying different aspects of the moon. And I will touch upon a few things when I discuss the glimpses of what we have learned. I have a detailed lecture of the Chandrayaan 2 science results after a couple of days. Maybe I will discuss in more details on Chandrayaan 2 during that lecture. Then, after having flown Chandrayaan 2, by the time we had lessons from Chandrayaan 1, Chandrayaan 2, and also when I speak about lessons, I speak about both scientific lessons and technology lessons. And the technology lessons enable us to achieve the soft landing on the moon and roving on the moon. And Chandrayaan 3 had 3 components of the mission. One component was the lander. The lander had 3 instruments, scientific instruments, which I have shown here in yellow color. Instruments for lunar seismic activity. This instrument was to measure any ground vibration on the moon surface. There was another instrument called Rambha Langmuir probe, which was, many of you are aware of the instrument called Langmuir probe, which is basically a plasma measurement instrument. So in the beginning slide, I have told you about a lot of plasma phenomena happening because of the introduction of this solar perturbation at the moon surface. So there is always a plasma environment very close to the surface of the moon. Electrons are always there. There is ionization of different neutrals. Okay. So always there is a plasma. You know what is a plasma? It is a combination of positively charged ions and negative ions, so that overall there is a charge neutrality. We call it a quasi-neutrality condition. It's a plasma, right? So same thing happens when solar energy comes. A lot of phenomena happens by virtue of which there is a sheath of plasma in the vicinity of the moon surface, and Langmuir probe was meant to study those. There was another instrument called Chandra's Surface Thermophysical Experiment, CHASTE, which is basically a penetrator this big, around 1 foot big, which was meant to penetrate the moon surface up to a depth of say 10 centimeter, and which was to measure the different temperatures at different depths up to the 10 centimeter and the moon's down the moon surface, and also to understand the thermal conductivity of the moon's regolith in the first few 10 centimeters. Then we had the rover. In the rover, we had 2 instruments. The one which I have shown in orange color, alpha particle X-ray spectrometer, and laser-induced background spectroscope LIBS, and both of them were meant for understanding the composition of the elements at different locations around the landing site. And there was a propulsion module. The propulsion module was the one which carried the lander and the rover from the Earth's orbit to the transfer orbit to the moon's orbit, and it helped the lander and rover to land. and it itself was rotating around the orbit of the moon. So it is a propulsion module. So it was carrying the propulsion of for doing all these maneuvers, all this job. So that propulsion module was carrying an instrument called spectropolarimetry of habitable planet Earth shape. So what it was doing, it was carrying an instrument which was studying the infrared signature of the Earth plus the polarization measurement from the clouds, from the water bodies of the Earth to understand, hoping that in future this technique can be used to identify a planet which is in some other solar system, which we call exoplanet, right? Which might have similar signatures, and we might attribute to those signatures to an exoplanet which is Earth-like. It was a preparatory experiment for that. The objective of this mission was to have ground truth of the surface and near surface properties of the landing site. So you have to understand the stark difference between the first two missions and the third mission. The first two missions, the objective was the chemical, mineralogical, and geological mapping of the moon. The entire moon was studied from orbital platform. In the third mission, it is the ground truth of the surface and the near surface properties at the landing site. It is a pinpoint measurement at the surface at a particular location. So I also must make a mention of the Moon Impact Probe, which was flown as a part of Chandrayaan-1. So many of you are aware, many of you may not be aware of this. The Moon Impact Probe was, I must say, mankind's first access to Moon's South Pole. It was the human-made object, first human-made object from Asia to have impacted on the Moon was from us, from India. And this instrument carried a mass spectrometer, which did the first ever successful observation of the daytime lunar exosphere, and it impacted almost at the South Pole. You can see the coordinates. In the picture also, you can see the approximate coordinate of the Moon Impact Probe, which went as a part of the Chandrayaan-1 mission. And Chandrayaan-3 landing location is shown here. In this picture, I am also showing the landing locations of the other mission in the near side of the moon. And this Moon Impact Probe studied the lunar exospheric noble gases like argon, neon, helium, plus molecular hydrogen. And a very important lesson which came from this experiment was the first direct detection of the lunar exospheric water vapor. So Chandrayaan-1 told about the presence of water on the moon, we all know. But Chandrayaan-1 told about water in its two phases. One is solid water ice, another one is water vapor. The information about the solid water ice came by virtue of the moon meteorology mapper that was near the polar regions of the moon. On the other hand, the vapor phase of water was detected by the Moon Impact Probe mass spectrometer, which was named as CHASE, Chandra's Altitudinal Composition Explorer. Now, Chandrayaan-1 has revolutionized, I must say, the perspective about the moon. Before Chandrayaan-1, we used to think that moon is bone dry. There was no question about any water on the moon. But Chandrayaan-1 changed the perspective disruptively, discovering the presence of water molecules on the moon. And this caused the resurgence of the global interest in the lunar exploration, to be more precise, hydration of the moon. So hydration is the term which is coined to tell about, to study or to investigate about the signatures of water in any form, in any celestial body is called hydration. Search for hydration feature. So that was a global interest which was afresh after Chandrayaan-1 mission. And also before Chandrayaan-1, people used to believe that moon is geologically dead. Billions of years ago, geologically dead means there is no enough internal energy left. Everything is dissipated in the deep space, which was proven to be wrong by Chandrayaan-1 mission by the identification or discovery of the signatures of comparatively recent signatures of volcanism, Recent signature means geologically recent, which is in the order of 50 to 100 million years. Recent doesn't mean whatever we mean in our everyday context. So moon's regolith completely absorbs impinging solar wind photons. That was a belief before Chandrayaan 1. After Chandrayaan 1, the understanding is that almost 20% of the solar wind photons are reflected back to space as energetic neutral hydrogen atoms. So it is not totally like a 100% absorbing sponge. 20% are returned, and they return as neutral atoms, neutral hydrogen atoms. And there was also another belief, um, you know, before telling that, let me tell you this, energetic neutral hydrogen atoms, which are known to be reflected from the moon, they were used as tracers to locate small patches of the magnetic fields on the moon. They are called mini magnetospheres on the moon. Maybe when Dr. Dania speaks to you about Chandrayaan 1, she will be able to tell more about the mini magnetospheres. So in the picture which I'm showing here, the right hand side, the bottommost picture shows some regions which are mini magnetosphere, which have been identified based on the pattern in which the energetic neutral atoms were coming out of the moon. They were backtraced where from they are coming, and this inference was used to understand the possible locations and the strengths of the mini magnetospheres on the moon. Moon doesn't have a global magnetic field, but there are patches of some residual magnetic fields. So Dr. Dania will speak more about this. And then also there was a belief before Chandrayaan 1 that lunar wake is devoid of solar influence. So what is meant by lunar wake? Lunar wake is basically the night side of the moon and beyond. Wherever it is a shadow region of the moon, where you are not expecting to get any influence of the sun. So that is called a lunar wake. So quite obvious, lunar wake should be devoid of solar influence. But that was the belief, which was proven to be wrong in Chandrayaan 1 because different populations of ions were discovered in the lunar wake region as well. Dr. Dania will speak more about this. And the lunar surface is vulnerable to impacts, and hence human settlement may not be possible on Moon. There was a belief. But Chandrayaan 1 proved that it has imaged a potential site. It is a buried lava tube for future human habitability on the moon. And there were many other scientific results from Chandrayaan 1, and Chandrayaan 2 drew motivation from the results of Chandrayaan 1. The Chandrayaan 2 mission is still continuing, and its objective is chemical, mineralogical, and geological mapping of the moon. And we wanted to have orbiter, lander, rover, all the three components, but we could not. So we are left with only the orbiter, and which are doing extended science from Chandrayaan 1. How it is doing extended science, I will give you some glimpse. And it was doing extended science by the improvisation of many of the scientific instruments which we carried in Chandrayaan 1. And also by envisaging some improvement in the observation strategy. And the left-hand side, you are able to see a picture wherein you are seeing a picture of the moon surface, right? But very clear picture of the moon surface. You are getting such a clear of the moon surface because Chandrayaan 2 carries a camera which is called OHRC. It is the acronym for orbital high resolution camera. High resolution is in the order of 25 centimeter spatial resolution in the Nadi direction. Okay, if you directly see from the Nadi direction from 100 kilometers of orbit, it can see with a 25 centimeter this big resolution. And important science results on water on moon, surface features, elements of moon surface, subsurface, exosphere, solar physics, all came from the Chandrayaan 2 mission. So this slide I'm not going to describe. This is a very thoughtful way of describing how Chandrayaan 2 was configured from Chandrayaan 1. Chandrayaan 2 was not configured ad hoc. Chandrayaan 2 had the lesson of Chandrayaan 1 behind, and also the lesson which came from the other contemporary missions. So if you see in this table, In the leftmost column, I have mentioned about the different payloads from Chandrayaan 1, High-C, SAR-2, MQ. I need not tell you about each and everything. That is not the purpose of today's lecture. But here I would like to show you that the specifications are given of the Chandrayaan 1 payloads. What are the corresponding Chandrayaan 2 payloads which have got the similarity in the purpose of investigation and their specifications? So if you compare each and every row, you will be able to see there are some differences in terms of specifications or in terms of observation strategy. Objectives remain same. Objectives are somehow increased, mostly remain same as Chandrayaan 1, but instruments are improved, observation strategies are improved in order to get some enhanced science. So here in each case, I have shown what are the enhanced science which are achieved in Chandrayaan 2, taking lessons from Chandrayaan 1. That is how we build one mission on the shoulder of the other mission. Okay, the Chandrayaan 3 is built based on the understanding of Chandrayaan 1 and 2. It goes like this. So I need not spend much of a time on this one because I have already made a mention to you. The sharpest eye around the moon at present is from India, thanks to OHRC of Chandrayaan 2. This is very important scientifically and technologically because, let me tell you about the technology part first. It is easy to understand. See, if you are able to see the small features in the moon in terms of small craters or small boulders on the moon, it gives you a better input to plan a future mission, a lander mission or a rover mission. You will be interested to know about small hazards on the moon surface whose sizes are comparable with the size of the rover or the lander. So for a better mission planning, these kind of high resolution images are of high demand. So that is one technological risk. Scientifically, when you are able to see the small size craters and the boulders, it gives you a lot more input about the processes of impact of the different small bodies of the solar system, like asteroids or meteorites which are coming and impacting on the moon surface, macrometeorite impacts. How do they cause dent on the moon surface in terms of a crater, like a crater, or what are the ejecta produced, how they are distributed? All these things, the impact processes can be studied better if you are having access to the small structures like small boulders and the small craters. So this scientifically also this way is helping, and also it is helping in another domain called geochronology studies. I will not go to the much details of the subject, where you are correlating the crater size distribution, different craters of different sizes, the statistical distribution of them with the possible age of that particular region of interest. So your information is getting complete. So it helps in that scientific aspect also. So while I will have a very detailed speech about Chandrayaan 2 later on, let me tell you in this slide, Chandrayaan 2 has got many scientific accomplishments in terms of hydration from the moon surface, hydration of the moon, surface of the moon, elemental composition, neutral and ionosphere of the moon. And also Chandrayaan 2 did solar observation. How did it do? And other things, maybe when I speak more details about Chandrayaan 2 in my subsequent lecture, I will speak during that day. But this slide is to give you an understanding of what are the different kinds of aspects of the moon Chandrayaan 2 has added the value of. Okay, so each and every point which I have mentioned is worth discussing for at least one day. But we don't have time for that. That is not the need of this lecture or this series also. But I am telling you all this. I have spoken about Chandrayaan 1 important science. Now I am speaking about Chandrayaan 2 just to give you an impression that sending a mission to moon, it is not only a matter of pride of a nation, it is definitely a matter of pride of the nation. At the same time, you have to, as science students, you also have to appreciate the scientific importance or first scientific motivation and what kind of values India has added to the community by virtue of the Chandrayaan series of the missions. I want you to appreciate that. So for that reason only, I am telling you so many things. Now from Chandrayaan 2, how it is going to lead to Chandrayaan 3? See, Chandrayaan 2, it is the orbital based observation. So there is an orbiter which is in the circular polar orbit, 100 kilometers almost. So it is not a pinpointed observation, but Chandrayaan 3 is pinpointed at a particular location. So there are connections between Chandrayaan 2 orbiter observations and Chandrayaan 3 lander and the rover observations. So in these, I have tried to express that different scientific experiments which are coming in, which are in the Chandrayaan 2 orbiter. On the right hand side, I have mentioned about different experiments in Chandrayaan 3 lander and the rover. They have some connections, okay? They have some scientific thematic connections between them. So if you are really having an eye to understand how to correlate the observations from a global platform like an orbiter and an in situ observation which is happening at the ground, and what are the cross payload observations, cross payload inferences you can make, really you can build up a story of the moon. Okay. And I'm using a term called cross payload science. What is the meaning of cross payload science? It is very simple. See, you might have 5 payloads in a mission. So one payload is destined to cater to a scientific objective. Second payload is for some other scientific objective, like this. But it could so happen payload number 1 and payload number 3 together can give you some other kind of science which is not possible individually. So it is a synergy of multiple payloads which are going to tell you about more. So 1 plus 1 not necessarily become 2. 1 plus 1 becomes more than 2 here. So these are cross payload science. So you can have a lot of cross payload science in Chandrayaan 2 and Chandrayaan 3 brought together. So in maybe another 10 minutes, I should stop. And I hope I could give you some almost vague, superficial idea, I understand, about the whole scientific aspects and how these things are evolving, how the program evolves to understand something more based on the previous missions. And that's why the Chandrayaan series of missions. Okay, so now let's go to the next one. So on 14th July 2023, we have launched Chandrayaan 3 from the Satish Dhawan Space Center, Sriharikota, second launch pad. And then all of you are aware that we didn't go directly. We had a few of earthbound maneuvers. Then we went to the lunar transfer trajectory, and there have been a few moon-bound maneuvers. This picture is not up to the scale. And then we were waiting for the sun to rise in the landing site of the moon. So our objective was to make the observations during the lunar daytime. So we were waiting for sun to rise at the landing site. And how this landing site was chosen? It was chosen based on scientific and technological criteria. Coming to the scientific criteria, if you have noticed, Chandrayaan 3 was envisaged to land at the higher lunar latitude. We call it not the pole, but the polar region. So we have to be careful. It is the polar region, not the pole. So higher latitudes are relatively unexplored scientifically, and it offers you a unique condition. Sun shines at grazing angle. So when sun shines at grazing angle, what will happen? The lesser deposition of energy and solar wind ions and electrons, and the physics is different. It is worth understanding, and also scientifically interesting topography. Technologically, these are all science. Technologically also, there are certain conditions on the global slope, the condition on the sizes of the boulders and craters, because your missions should not be jeopardized. After having everything done, you land on some place where there are big boulders and your rover gets obstructed, or you have a very big shadow which is cast on the solar panels, you are not able to generate power. That's what I have mentioned in the next point. Shadow analysis, power generation, and also communication with the earth, that feature. So all these are technological criteria which had to be fulfilled. So scientific criteria along with the technological criteria prompted us to have a few landing sites And that's how we were at that location. So on 23rd of August 2023, Wednesday, 1804 hours IST, we achieved the soft landing on the moon. And by these, India became the first country to have soft landed at the higher lunar latitude and the fourth country to have soft landed on the moon. And Honorable Prime Minister of India named the landing location, landing site of Chandrayaan 3 as Shiv Shakti Point. Here, I also would like to mention Honorable Prime Minister of India has also named the landing or the impacting site of Chandrayaan 2 lander as Tiranga. So you are seeing the picture of the control center during that eventful day, and which made India proud, Indians proud, and internationally, it was very much impactful, not only in terms of science, but also in terms of the technological prowess of India in achieving a complex mission like soft landing on the moon. So, coming to the Chandrayaan 3 mission update. So, what were the original objectives of the mission? It was twofold: to soft land the lunar lander rover module on the predetermined landing site at the southern high latitudes of the moon, and demonstration of the rover movement on the moon surface. So both original mission objectives have been successful, and the rover has moved. You are able to see here in the bottom left picture. This is the trajectory of the rover. It has traversed a distance of around 101 meters on the moon surface. Here I forgot to mention one thing. The name of the lander, lunar lander, was Vikram, and the name of the rover was Pragyan. Pragyan means wisdom. Vikram is valor, and also after the name of the father of the Indian space program, Professor Vikram Sarabhai. And after having accomplished the mission objectives, the original mission objectives, there have been a few extended mission accomplishments, which are demonstration of hopping of the lander by refiring the engines, which happened on September 3rd, 2023, and subsequently the return of the propulsion module, which was so far around the moon's orbit, around the moon in the lunar orbit, which was brought to the Earth's orbit. And those were some preliminary steps towards the lunar sample return mission. Actual lunar sample return mission is much more complicated, but these two basic things you have to do. You have to jump and you have to transfer from one orbit to the other. Very, very vague sense. Those we did. So that's it. And these pictures have become iconic. Vikram landed on the moon surface. This has become an iconic picture. This picture was taken by the camera in the rover. Okay? And these pictures, you were able to see the captions. I need not explain. RAM deployed position captured on 25th of August 2023. And 3rd September 2023, when we have already hopped to some other location, you see the distance, the difference in the local texture. It shows a different part of the moon we have landed, but not very far, a few tens of meters apart. So coming to the next part. So there have been a fast cut scientific observations of from Chandrayaan 3. Detailed scientific results will come. Our scientists are analyzing scientific data and they're in the process of preparing their manuscripts. They're about to submit to the journals. But in order to tell you a few things which have been published in the ISRO website about the fast cut observations from Chandrayaan 3, where the first ever detection of sulfur on the moon's regolith, along with the detection of trace constituents like carbon, nitrogen, phosphorus, titanium, and a few. The quantifications are in progress, and also temperature profiling of the lunar regolith up to first 10 centimeters, and also to quantify the thermal conductivity. Then a few of ground vibrations of the lunar surface also were recorded, which were not due to any artificial event like movement of the rover or deployment of some instruments in the lander. They were all natural events, which are also under the study by the team, and also characterization of the near surface plasma, lunar plasma, by the Langmuir probe. They indicate that a very few numbers of electrons per cc are present, and there is a strong dependent on the local time on the moon. So what happens, we had the mission for one lunar day, and as I've shown, on 3rd of September, we had 23rd of August we landed, and 3rd of September, by that time we completed all these experiments, whatever we wanted to do, and we did hopping, and we did a series of processes for putting the Chandrayaan 3 systems into sleep gradually in a systematic way. And we declared that the mission is successful because whatever we wanted to do, we planned for one lunar day. You have to remember, one lunar day means 14 Earth days, okay? It is not like 24 hours day and night. It is 14 Earth days is equivalent to one moon day, similarly for night. So that was the objective, and which was fulfilled, and that ended the mission. And then coming to the future of the lunar exploration, that exploration the lunar poles is really scientifically important, especially to study the permanently shadowed regions of the moon, and also to search for different volatile materials in those permanently shadowed regions, which said to encapsulate the history of the early solar system. And also in future, the drilling and the sample collection of from the moon, in situ sample handling and analysis, and also negotiating different difficult kinds of terrains in the moon, especially going down to steep craters and coming up. And this also involves a lot of innovative designs of rovers and other technologies. And also in future, sample return missions, and in still future, the use of the lunar first sight, not only science of the moon, but science from the moon. You can do a lot of science from the moon, sitting on the moon, because we have got several advantages of using the moon as the vantage point, because there is no thick atmosphere, there is no haze, or there is no aerosol scattering. Moon can be used as an observatory. The far side of the moon, which never sees the Earth, which is comparatively more RF quiet, radio frequency quiet, they can be used as the region for radio astronomical observations. And also from the moon, you can look at the Earth with a better resolution in terms of spatial resolution and spectral resolution, to know what is happening to the Earth in a big scale in terms of global warming, suppose. All these things you can study from the moon. So a lot of opportunities are there in the future lunar exploration, not only to study about the moon, but also to study about Earth, and also of the space, keeping moon as a vantage or a strategic point of observation. And I will end my deliberation with a few resources. You can take pictures of the next few slides, or you can take screenshots of a few slides which will be useful to you. One is the Indian Space Science Data Center. This website is very important because it houses the space science data of the Indian space missions. There will be a lecture on this, and Chandrayaan 3 data will be made public after a couple of months. So currently Chandrayaan 1, Chandrayaan 2 data you will be able to find here, and you can register yourself and start using right away. So this is one very important information. Also, there is a QR code. You can scan this. You can take a picture of this. There's a book. The name of the book, I can show you the book. I have it in front of my table. I don't know whether you can see my video. So the Lunar Saga. This is a very crisp book which tells about why moon is important scientifically, and the achievements of India in the exploration of the moon. Whatever I have told today, plus some few extra, not a few, lot of extra information are also there in this book. This is available free of cost, and you can scan the PDF of the book, download the PDF of the book by scanning the QR code. And second useful information is a book which is about the space exploration itself. Although I told about the moon's exploration only, but this book will allow you to have a perspective about the space exploration in general, how a space exploration is, how the space missions are defined, configured, and what is exploration all about. So if you scan this QR code, you are going to get access to the PDF of this book. Very small book, but very useful for the students. So with this, I thank you for your kind attention and this opportunity. Thank you all the students who have attended this lecture, and thank you IIRS for this opportunity.